welcome to my channel. So in this video, I'm going to introduce a solution for this Leetcode question called Spiral Matrix 3. And also at the same time, I'm going to introduce briefly about the steps we should follow in the real interview. So let's get started. Remember, the first thing in the real interview is always try to understand the question. If there is anything unclear, please bring up the question to the interviewer and at the same time think about some edge cases. So let's go through this piece of description together. So on a 2D grid with R rows and C columns, we start at R0, C0 facing the east. Hence, the northwest corner of the grid is the first row in the column, and the southeast corner of the grid is the last row in the column. So we walk in a clockwise spiral shape to visit every position in the grid. So whenever we move outside of the boundary, we continue our walk outside of the grid. So eventually we reach all the spaces of the grid and we need to return a list of all the coordinates representing the position of the grid in the order they were visited. So suppose we have a 5x6 grid and we start at position 1, 4, which is this one, and the trace of the walkthrough is something like this, and we record the sequence of each of the cells, the sequence of the coordinates of each of the cells into this output. So we can see that the input, the matrix, the grid is never going to be empty, and the initial position is always going to be valid. So in this case, I don't think there is too much of the room for us to think about edge case. So let's get started to the next step. So the next step is about thinking about solution, discuss with your interviewer, talk about some runtime space analysis, and then after you get an agreement, you can start doing some coding work and take care about the correctness, readability, and also the speed. So let's go over this piece of code together. So we define two helper functions. The first helper function is to see whether the current position is within the range. So essentially we are saying whether the current row is within the range and whether the current column is within the range. So we close it. So the next thing is, the next helper function is essentially try to set the current position, the coordinate of the current position into the matrix. So I'm just going to close it. So let's go through the body of this major function. We have 4 parameters, RC, R0, C0. So we need, it's like onion peel steel. So we need to first compute the layer, the maximum layer. So we will need to go through. So for this we don't include the innermost layer. So instead, let's say for this example, we only have 4 layers, which is something like this. So this is essentially the first line. We compute how many layers we need, and we will need to initialize the matrix, which is a 2D matrix, and the second dimension is a fixed length of 2. So this is an iterator. It's just the iterator about the coordinates we are going to set into our matrix. So initially we set R0, C0 to be the first coordinate in the matrix, and we start from the current layer, which is 1. So in each layer, the length so in each layer we are going to do something like an onion peel. So let's say for the first layer it is something like this. If you see my mouse, I'll do it again. It's like this. So you can see the length of each side. It's actually, I'll just say it has 2. Like for the left column, I would just for the right column, it's just like this, from 2 to 3. For the bottom row, it is from 4 to 5, and for the left column is 6 and 7. For the upper row, it is 8 and 9. So you can see that in this case, we don't have any overlap between the rows or the columns. So this the length for each layer is the layer times 2. So let's say we are first going to do the right column. So the right column, let's say for this one, for the first layer, for this it is 2 and 3. So we will essentially we just go through the row index with the first column and add the corresponding coordinate into it. And similarly, we are going to do the rest things for the bottom row. So for the first layer, it is 4, 5. We are going to do the left column. For the first layer, it is 6 and 7. For the up row, for the first layer, it is 8 and 9. So and at every position, we are trying to see, we need to make sure that the current position is within the range, is within the grade. Otherwise, we will just continue. And finally, we should be able to visit all the cells within the grade, and we just return the matrix. So that's it for this code and the solution. And remember, after you're done with coding, please do some testing accordingly. So the runtime for this solution is going to be, let's say I'll just write it down. The runtime is going to be let's say max of R or C. So it is going to whichever is the maximum so whichever is the maximum between R and C, we are going to do the square on top of it. This is the runtime. So let's say if R is larger, then it is R squared. If C is larger, it's C squared. So that's it for this coding question. If you have any question about the solution or about whatever, feel free to leave some comments below. And I also have some summarization about different types of the question in this sheet, which I have already shared in the video description. So feel free to refer it during the time you prepare for your interview. And thanks for your time watching this video. I'll see you next time.